playlist. So the benefit of this, obviously, is if you're working on something and you can't get it to work when you're at home, you can always go back and watch the video. You can stop it, you can pause it, you can rewind and catch something again. Hear things more than once. Not that you want to hear my voice again and again, but it's there for you when you need it. Okay. So I tried doing this as an experiment a couple years ago, and I did it for a bit, and then I stopped. And as soon as I stopped, or a couple times, I messed up the videos. I used to have to record them and then upload them before YouTube had live streaming. And when I messed up videos, I had half the class in a panic saying, "Where's the video? Where's the video?" So I made sure I will try to do it now in every class, and I'll do this all of our classes together. Okay, so you can always go back and have these as a reference. Hope will help you learn a little bit better. Okay, I'm still going to encourage you to come to class, because again, if you're sitting at home and all you do is watch the videos, when you have a problem or there's something you don't understand, well, you have to send me an email and wait for a response, right? I can't walk over to your computer, look what's going on, and help you. You also can't learn from each other nearly as well, and you're probably going to learn a lot from each other and doing things together. I'd still encourage you to be here, and again, this is here as a resource and as a supplement for you. So the videos will be here. One of the things I'll do on Blackboard, I won't post links to every video. In the tools and resources, I will just post a link to the playlist. So there'll be a COMP1030 playlist. You can just click on there, you'll see all the videos. So make a new video. Every time we take a break, I'll stop the video. So every week there'll be a part 1, part 2, part 3, generally. Okay. And in fact, you can see previous lessons in other courses actually here. So if you want to see stuff, and so here's my Friday class. This is a second-year class for the programmers where we're doing advanced JavaScript. So there are my videos from Friday. So all of my classes will be on here. So we've talked about prior learning assessment. We'll skip some of these stuff. Anybody ever done this? Anybody ever actually put together a computer before? Some of you. It's probably a useful experience for you to take them apart. This is not a hardware course. You don't have to do this. But in order to understand how programming works, it's kind of useful to understand just a little bit about how computers actually work.
Or if you've never built one, but you've definitely taken a few apart.
Well, that's good experience. And when I say computer, I don't necessarily mean a computer. You know, it might be a tablet, it might be a smart device, it might be a sensor, it might be a phone, anything. All of those, anything with a chip in it, a processor, really is a computer. Right? They used to look like this. Well, that was one computer that filled the whole room. This was kind of the first generation of computer. They've been around since the 40s.
I was actually talking to my parents a lot about this. My parents are a bit older, and they used to tell me all the time about these computers and where they first came from, and how a computer would literally fill a whole room, and all it could do is, you know, simple calculator functions. Yeah.
So this says 100 feet long, 8 feet tall, and it used 150 kilowatts of electricity. By comparison, something like a sauna today that can turn water into vapor is about 5 or 6 kilowatts. And in fact, in the 60s, my mom was one of the first women to work for IBM in Canada, and she worked in a room like this as a computer programmer way back in the 60s.
My dad used to do it. He had punch cards.
Yep.
And they would punch the cards back out.
That's right. There you go. So all computers, all they really understand is machine language, which basically looks at its very simplest like this. Everything you do, every instruction on every device basically boils down to a 1 or a 0. A 1 meaning on and 0 meaning off, right? And 8 of those, so that's binary, 1 and 0. And we even see that today, right? Let's say we're signing up on a web page for something. We've got a registration form. And on our registration form, you know, it might have boxes where we put in our email address, we create a password, and then there'll be something like this. Gets stored as, you know, something like subscribe to the newsletter, yes or no. Just gets stored as a simple 1 or 0 in the computer. So then we start putting these combinations of 1s and 0s together, and we get letters and numbers, and that's kind of how we issue instructions and tell our machines what to do. So everything we do at its base level, we're not really going to work at this level, but this is what happens under the hood. And zeros, right? So we have every combination of 8 makes for 1 character in effect. Again, these are on Blackboard. I'm not going to read them all to you. It's just by way of background. So even when we think of things we can see, for example, digital images, right? All the images on your screen, they're really just a different collection, different combinations of 1s and 0s put together. Okay. So something like my initials would be, that's how it would be represented in binary, right? The R is 2 ons and 6 offs in that order. The F for my last name for Freeman is in that. So there's that's how a computer would represent my initials, basically. So we're not going to work at this level, but everything we do, a computer is going to translate into this stuff. So largely what we're doing is we're taking information from our users. Maybe that information is something like a photo they've uploaded to their photo gallery on Facebook. At the end of the day, that processor is going to convert it all to 1s and 0s, store it in memory, and do some kind of instruction or execution. We'll talk a bit more about how Facebook works in a minute. So here are some of the different languages we can use to give us more kind of language-like syntax that ultimately will compile and convert down to 1s and 0s. So we're going to work with C# in this course. In January, when we do Intro to Web Programming, the language we're going to use is PHP. You're also going to be taking a number of courses here at Georgia. I think you're going to do at least three courses with JavaScript, and your last one will be with me. That'll be next January in your last semester. Anybody worked with any programming languages before or learned any other languages besides these? Alex, what have you learned? C++? C++, Max?
Ladder logic with PLCs.
Okay. Anybody else used any other kind of language? You've used Java and both Java and JavaScript, or only JavaScript?
Visual Basic and Java.
Okay, Visual Basic.
It was long ago.
Mm-hmm. Yep. Okay. So at the end of the day, they all basically do the same thing, right? They're just different ways to communicate. Okay, so we're going to teach you several different languages through the program. And when you're out working, the idea is we want to build your resume. So, you know, Kane, you can get a job as a PHP developer. As a C# developer, well, you're going to have all of those skills. Okay. But all of them, really, whatever language we teach this course in, it doesn't matter, because all the programming languages, they all have the same components, the same basic structure and logic, just like different spoken languages, right? Hindi and English are really just two different ways to communicate. Okay, but we can largely say the same things in those different languages. So all of our code, what we write, that's what's called source code or source code. Okay. So ultimately, we need some kind of application that will take the source code, the instructions we write, an instruction like, say, print or close or open or load, and we need that converted down to 1s and 0s. So that process is called compilation or compiling. So we need some application, and in this class, we're going to use Visual Studio to do that compilation. One of the nice things about a program like Visual Studio is it will catch and show us when we make syntax errors. So when we type the name of a command wrong, it'll tell us, it'll underline it in red, and our code won't compile. We're going to get an error message, and the program's going to say, hey, you've made an error, and it's on this line. And this is what the error message is, so you need to fix it before your program can run. So we write the code, see if it compiles. If it doesn't compile, try and fix the errors. If it compiles, then we have to run it and see if it works the way we wanted it to work. And usually it doesn't. Go back, fix. So that's the process. We spend a lot of time fixing our errors. So one of the things that will happen a lot in class is you're going to get an error, and you put up your hand and say, Rich, I have an error. Well, the first thing, what am I going to say in response to that? And you say, I have an error. I'm always going to ask you the same question. I said it on my Thursday class about 15 times. I'm going to say, what does the error message say, right? So the first clue when something goes wrong is read the error message, because that's a hint as to what we need to fix. So C# is a language. It's been around. It's been created by Microsoft. For those of you, some of you have learned Java or JavaScript or C++, the syntax and structure of C# will look very familiar. And most of the languages we're going to learn in this course have a similar, they're all based on the original C language. JavaScript, I think you guys will learn JavaScript next semester. It's based on C, because it's based on Java, it's based on C. We learn PHP, it's also based on C. So fortunately, the structure and syntax of all the languages you're going to learn here at Georgian, they're all fairly similar. So it's pretty easy. Once you know one, really easy to quickly learn another one. Basic, you said you learned Visual Basic, that's a little bit different. Okay. So here's typically when we have something we need to build, until, well, even when we become experienced developers, rarely do we get requirements, sit down and start coding. Okay. What we typically do is especially when we're learning, is we've got to plan out what's supposed to happen. So we need to build an application, build a web page where users need to be able to do something. So typically what we want to do, and there's some tools, and we'll look at some of them today, how do we actually plan out what's supposed to happen? It's easier first for us to figure out what's going to happen, plan it out, and then try to write the code. Okay. Think about if you were going to have a brand new house built. Okay. Are you just going to buy the lot, hire a builder, and have the builder show up on the first day with their work crew? Right? The builders come and they say, Ernest, you know, what do you want us to build? We're ready, right? We've got the digger, we've got the backhoe, we've got 10 people here. What are we building? Why not? Right? What's going to happen long before the builders ever show up with all their tools and their construction crew? What are you going to do before that? Okay.
You're gonna plan the, all you're gonna do.
Yeah, exactly. You're going to have maybe an architect. You're going to hire somebody to draw out exactly what's happening, right? When the builder shows up, they don't want you standing on the front lawn saying, put the door here and make it a double door. No, maybe a single door. No, a double door. And put a window here. And I want this color brick. You have to decide all of that stuff first. Because you only want them to build it once. Build exactly what you want, and then you want them to go away so you can use the house, right? When we're building applications and websites, it's the same thing. While we're actually coding and putting things together, we don't want to be deciding, are we doing this or are we doing that? We want to make all those decisions and do all that planning first. This is how the website works. This is how it will look. This is where users will go. This is what they're allowed to do. This is what they're not allowed to do. We want to figure all that stuff out and have a plan. And we actually give that to our client and have them check it over and approve it. And if they, so that way we can go and build the website and they can't keep calling us every day and saying, make it do this. No, make it do that. No, change it again. Right? Because then we get into me paying Wilson over and over again to change his work. So we want to plan out what we're doing first and then build it after. We'll check for syntax errors, we'll check for logic errors, and then we'll debug. We're always going to spend time, right? If you spend 4 weeks building a website, you better, if you figure it's going to take me 4 weeks to design and build this website, you better tell the customer, your boss, I need 5 weeks, because that 5th week is going to be there for you to test it and find and fix all the errors that happened when you built it. So it goes something like this. We'll design it, we'll code it, we'll check for errors, we'll test, we'll debug, and then we may have to do this again until it's ready. So we need to make sure we allocate time. So in your assignments, my suggestion is if you have an assignment, a programming assignment due Sunday night, don't plan to start it Sunday. You need to plan to have it finished, the first draft, by maybe Thursday so you can test it. And then if you have errors, you can email me and ask me for help. rather than emailing me at 11 o'clock Sunday night when I'm sleeping so I can come in here Monday morning, right? So the other thing that often helps, particularly new developers, it's what's called pseudocode. So what pseudocode is, and here's an example here, which I'm not going to read to you. You can read it. It's not specific to any language, but when we have a task, we have to build something. Could be a mobile app, a desktop app, a web application. We basically just write out all of the steps that need to happen. So something like a simple paycheck calculator, right? Somebody needs us to build one of these for them. Before we write the code, if we figure out all the steps that have to happen, that's going to make it much easier for us to write this. Figure out what has to be done first and then code it second. So we probably won't write pseudocode after this course, but we will at the beginning, getting used to the idea of figuring out, okay, what are all the things that have to happen here? And how do we make this work? And there's some tools for this, and we're going to use a few of them. And one of the visual tools, for some people, pseudocode is great. If I just write down step 1, step 2, step 3, my thoughts are organized and I can figure out what to do. A lot of other people are more visual, and actually seeing it visually as a kind of a map or chart is another way. So this is a really simple flow chart. So these are common symbols, stop and start. This is some kind of input and output, this symbol. We'll talk a lot in this class about inputs and outputs. What would we mean by inputs and outputs? What?
Like a sensor or like maybe a manual input?
Okay, yeah, either one. So an input could be a sensor, like a smart meter, but it could also be something we're asking the user to give us, right? What would be an example of something, some program we might write on the web where we're asking users to give us input?
Like when you're calculating like the body mass index, you could ask for their height or their, weight.
Right, so the input would be somebody's height and weight, and the output would be our program would then calculate and give back to them their body mass index.
Like input would be the login page.
Yeah.
And output would be the home page of that login customer or whatever.
You got it, right? So the user gives us a username and password. That's the input. Then we do some processing. What kind of processing would we do after they give us a username password? Yeah, we're going to go and check our server. Do we have that? Does that username and password exist? And we could have a couple different outputs, right? If we find them, we're going to take them maybe to the home page. What would be the other possible output if we don't find them? Exactly. We need to give them some kind of indicator that we didn't find them, which means either they have an account and they made a mistake, or maybe they don't have an account. Right? So everything we do, all websites, all the sites you go to every day, this is really all they do. Well, there's a series of inputs, processing, and a series of outputs. And we'll look at a few of those sites today and think about how this works, right? Every website you use. What's the first website you go to every day?
Google.
Google? Okay. What's an example of an input Google might use? Yeah, so here, let's just pull up Google. So there's our input right here, right? Google wants us to give it a search term. What kind of output? Yeah, so if I search input output and click this, it triggers a process on Google, and Google gives me output, hopefully that matches what I want. What's another site that you go to that you're on every single day besides Google?
Blackboard.
Okay. What kind of inputs might there be to Blackboard, either for you guys or for me?
Even when you click on a link, it's still an input.
Yep, because you're making a request, right? We're telling Blackboard what we want to see. What other kinds of inputs do you think there are on Blackboard?
It's on the left side, links. If you click like assignments, it'll show the notifications.
Yep. There are no assignments here. How do assignments get here?
Upload.
Right, I add them as an input, right? I add them as an input, and to you they show as an output, right? Something you can see as soon as I put it up there. Okay, what else besides Blackboard and Google? Give me one other site you go to.
Like if we want to search for folders, like on the left side, if we want to search for folders, like the links, search.
Yep.
Search option, that would be an
Those
input.
those would be inputs too, sure. So if we'll go to Reddit. Okay, so if I click something here, what kind of inputs and outputs does it allow for here?
If a user submits a link to a web page, that's an input.
Yep.
The output would be said web page.
Yep.
Also, I guess, upvotes and downvotes. If someone likes something, they can upvote it.
Yep.
Output would go up.
Every time you click like, you're providing an input, right? Output, because it shows you, it increments the number. It shows you how many people have given that input of like. Same here, right? All of these comments, they come from the users. So every time somebody hits reply and they go ahead and submit, they're adding another input, right? Facebook's really the same. So all of these sites, all the things we use every day, it all works the same way. So the good news is once we understand how this all works, well, we could build anything because all fundamentally it's just inputs, processing, and outputs. Okay. So we can also think of it like this in some kind of a loop. We ask users for something, they give us inputs in different ways, and there's different ways they could provide those inputs. They might type, they might click, they may do other things, and then our application processes stuff and it spits out other things back to them. Okay. And typically, not in all programs, but typically these things will happen in order, right? So if you see those three input statements, name, name, street, and then city, and they'll typically get output in those same ways. So our programs will execute in order unless we tell them to execute in a different way. That's what we can expect. Okay. So here would be another really simple example. We ask the user to give us their age. We give them a display, a prompt. We ask them for something, and then we spit out a message back to them, basically just echoing what it is they've given us. A really simple example. Now, most languages have a few rules around how these things work. Okay. So typically, we're going to talk a lot. You'll hear this word variable a lot. This will be new for a lot of you. A few of you are probably familiar with the idea of a variable. Anybody want to take a stab at explaining what does that word variable mean when we're talking about a program? Alex?
That's a word that we use to describe a number or a set of characters.
Yeah, it could be either of those things. Anything you want to add to that?
A number that can be changed by, the computer.
Yep, could be changed by the computer.
Or, it's like user or something.
Yeah, or it could be changed by the user. Okay, so for example, on a login page, let's just load a login form here for a minute. We'll go here, right? So the values of username and password, we'd say these things, these inputs are variables, right? Because they change. If we all go here and type it in, we're probably all going to put in something different, right? We all have an email, we all have a phone, but the value of my email and Kane's email, they're going to be different. So we say that value is a variable. It changes. Another example might be this. Let's go here. We're going to spend a lot of time looking at Amazon because it's a good example of many of the things we're going to talk about. Let's add something to my shopping cart. Oops, let's try to add something to my shopping cart. Oh, I guess I have to pick a size. Pick a size.
That's usually good. Just generic shoes don't really work.
That's true, right? So this is a variable, right? It shows me at any time how many items are in my cart. Right now there's one. If we go and look at my shopping cart, there's several different variables here. Right? There's the number of items here. What are some of the other variables you see displayed on this page? They're values, but they might change.
Price.
Yep. So the price could change. What else could change? Either the program might change it or I might change it. Okay. Yeah, quantity, right? So this is something I can change. It would be great if I could change this one. Amazon can change that variable, but I can't, right? They can decide to sell me that shoe for less. But I can change this one. When I change this one, if I change the quantity, we'll see several other variables on the page change. What other variables is Amazon automatically going to change if I change the quantity variable?
Price.
Well, they might change the price. Maybe they'll give me a discount if I buy more than one. Yeah, but the total of my cart's going to change, and the number of items, which we can see both here and here. So if I buy 2, well, it won't even let me because they only have 1 available, right? So there was some processing. Nope, sorry, you can only buy 1. We don't have 2 to give you. But you can see different variables. So we need to kind of understand what is a variable in order, I mean, at the end of the day, this is the kind of stuff we want to build. Somebody says, hey, I want to sell my products online. I need a shopping cart. We need to be able to do it. So variables are key. So some of the variables our program is going to control, and some of our variables we're going to let our user control, right? Like let's say their password. Maybe you can choose your own password. In this site, no, we're not going to let you choose your password. We're going to assign it to you.
Well, a lot of times if they assign a password to you, you're still controlling the variables that you're inputting.
Yep, that's true. So we have a few rules in any language just to keep in mind, and we'll get to practice this, but there's a few rules. One thing to get in the habit of, both with variables but in general, is whenever we're naming things, like we're naming a web page, naming a variable, naming a folder, we don't want to use spaces. So for example, if we're going to ask our user to give us their first name, what we don't want to do is create a variable called first name. The space, when we try to reference this, the space in here is going to cause a problem. So if we want to have first name, we really have 2 words, but we don't want a space. There's a few different ways we could write this without a space. What options would we have?
Plus dot name.
Sorry?
Plus dot name.
We could try first dot name. That would be okay in some programming languages. Others wouldn't like the dot there because the dot means something else.
Underscore.
So that's common, first underscore name. Now my program would understand that that's one item, one variable. What else could we do?
Just for your own personal reference, you can just capitalize the first letter of each word.
Yep, there's a term, it's actually typically written like this. Typically the first word is written lowercase. We could capitalize it, but then we do this to make it readable. This coding style has a particular name. It's very common, particularly in Java and JavaScript. Anybody know what that's called? Yeah, it's called Camel Case, right? Because the first letter, it's like the hump on a camel. We're low, and then every time we have a new word, we have a capital letter. So particularly if you see JavaScript code, we'll see this. Both of these are correct. Some programmers prefer this style, others prefer this. But what we don't want to do is leave spaces. So when we create any variables, web page name, folder names, we should get in the habit of not including spaces in there. And usually, coming back to the dot, usually we don't put punctuation in there other than an underscore, typically. And one other rule usually is they have to start with a letter. You can have a number somewhere in there, but typically not the first character. Okay. And what's also a good idea is to make your variables descriptive. If you're asking someone for a password, don't call it variable 6. Because later on, you won't know what variable 6 means. If it's to store a password, call a password. If it's to store a product code, call the name product code. So as I've said, this camel case structure is very popular, and you'll see it in lots of code examples. I'll probably use it in all of our classes. Well, I'll use it in most of them, maybe not next semester with PHP. So let's talk about a few other examples. Let's go here. Oh, you know what? Sorry, I ran a little longer. Let's actually take a pause here. It's 10 after. I'll stop my stream. Let's take a 10-minute break. We'll come back at 20 after.